look at the one end of the spring. One end of the spring is connected to block. The other end is connected to a wall, and that wall is again in turn connected to wedge. Okay, no. Okay, let's assume that one. Let R be the displacement of block with respect to wedge, and let the wedge have displacement x2. What is R? XR, we can also write it as XR. What is XR? Displacement of block with respect to wedge. And what is X2? Let it be displacement of wedge here. This one. So this X2 is what? Like with respect to ground, XR is this one. I think these are the very primary things which are very important. What is XR? Displacement of block with respect to wedge. You can get into the problem very easily from here. Let's go for conservation of mechanical energy. Then initially, what is the state of this? There'll be some spring force will be acting. The kx0 will balance m1g sin theta. Okay, agreed. This will be initial spring force. Now I'm going to slightly pull it down and release. Then this is the additional. This will be how much I'll pull down. Let me pull down by distance xr with respect to wedge. Then what makes the wedge to move? Because of normal contact, and the wedge will start moving here. Let x2 be the displacement here. Now if I differentiate this dx2 by dt, what do I get? I'll get the velocity of the block or the speed of this wedge. Similarly, if I differentiate dx by dt, dxr by dt, speed of the block with respect to wedge. I know speed of the wedge. Can I bring the other quantities? So here, first we'll calculate the displacement of block with respect to ground along x and along y axis. So it will be x1, x will, for that, it will be xr is equal to xr cos theta, displacement of block with respect to wedge along x-axis. Yeah, it should be equal to, that should be equal to displacement of block with respect to ground. All right, only x1 it is understood. It will be towards left negative. Okay, if I take this is positive, this you have to take it negative, minus of minus x2. So what is this x1x? Displacement of block with respect to ground along x-axis. Oh, this is, I think, xr already is there, no? Along x-axis, xrx. Hope I think I have. So what is xrx? Displacement of block with respect to wedge along x-axis. That should be equal to displacement of block with respect to ground along x-axis minus of displacement of y. Why negative sign? This will be towards left positive, towards right negative. I'm picking. So this should become equal to xr cos alpha. This we don't know. So x1, if you are interested, you can go for x1x. That will be better. This will be, and this is the that of the wedge will become plus. So I came to know now xr cos alpha plus x2. Similarly, xry, displacement of block with respect to wedge along y-axis should be equal to displacement of block with respect to ground along y-axis minus displacement of wedge with respect to ground along y-axis. What about this? This will become XR sine alpha. This is unknown thing. This will be 0. Why 0? Because the wedge will not move along y-axis. Wedge will move only horizontally. That's why it is 0. So I got x1y and x1x. If I differentiate these things, dx1x, what do I get it? Speed of the block with respect to ground along x-axis. This should be equal to dr. Okay, first what you have to get the expression. Okay, in terms of that will end up, okay, this will become cos alpha dxr by dt minus velocity of the wedge. Let me write v2, and this relative velocity, let me write vr. One step will write in detail. That's the first step. In books, it's there, but I think the written final answers you find very difficult to understand. And that's why I just picked up. This is what like V1X only. This is VR and this is V2. If you want, you can directly go for it. Let the velocity of the speed of the block with respect to wedge by VR along the incline. Then similarly, V1Y will take it. So this should be equal to VR sine alpha. Differentiating this equation. Okay, now I can write an equation. So now what is the equation we can write here? The energy equation, I'll take help of it. And what all form the energy is available in the kinetic energy of the block? mv1 x square plus mv1 y square plus that of the wedge mv2 square by 2 plus elastic potential energy of the spring. What shall I write elastic potential energy? Kxr, you have to write it. Because already, sir, why you're not taking the gravity? m1g sine theta will be balanced by kx naught. If I further displace it, I'll be displacing it with respect to what? With respect to wedge, no? So how much further elongation of the spring? Equal to xr. So displacement of block M1 with respect to wedge or increase in elongation of the spring from equilibrium position. Both are same. This is okay. Let me add now the sentence. It'll be much easier for you to understand. What is XR means? Or increase in elongation of spring from equilibrium position. Now what to do? Okay, finally we got it. Shall we differentiate this? Shall we differentiate what to do with that XR? What to do with XR? XR will become VR. V1X will become A1X. This will be A1Y. So I think I had to work out some relative motion here. Conservation of net. So what is the net force acting on the system? I'm bringing it like this. So this will be N1. Now I'll bring the forces here. Then M1G sine theta. So this, okay, this will become K x naught plus XR. So somewhere in the corner we'll write it. Kx naught is equal to initial elongation of the spring should be balanced by M1G sine theta. Now we'll differentiate this. What we have to find out the frequency of small oscillation. Either you replace V1X in terms of V2, V1Y in terms of V2, the problem will be solved. But what to do with XR? So I need some relationship. So again, I'll come back to this one. V1x, we can write it as the same equation already we have here, no? These things I'm going to take help of. Can we write directly this equation or not available? I am just leaving it to students. Can you write this equation in this way? The best question is what your teacher is asking. So is this equation justifiable? Yes, very much. No, we are differentiating now. No, what we want, we need. So all our unknowns are there. All these are unknown. So I'll go for conservation of linear momentum. From the conservation of linear momentum, so initially the system was at rest. So this will become m1 v1x minus m2 v2. What is v1x? V1x equal to vr cos theta minus v2 minus m2 v2. V2 is equal to m1 vr cos theta by m1 plus m2. Okay, now what I can do is I'll replace VR in terms of V2, V1X in terms of V2, V1Y in terms of V2. Then I'll differentiate. So what you are going to do with XR? XR also should be replaced, no? XR should be brought in terms of X2. Able to make it out? So this will be, so now we'll solve for VR. Cos theta, cos alpha, no, it is. Yeah, this is the one primary equation which is going to help us a lot. Now, what I can do is like this VR, I'll substitute it, I'll get V1X, V1Y. Okay, already this VR is there. VR I'll substitute here. Oh, sorry, this VR I'll substitute here. Then I'll get V1X in terms of V2. This VR I'll substitute here, then I'll get V1Y in terms of V2. So I brought everything in terms of now what like V2. If I can show that wedge is executing SHM means even the block also will execute SHM. After this, what to do with this? This, if I differentiate, what do I end up? dxr by dt. dxr by dt is nothing but the VR, no? If you want, you replace this xr by x1y by sine alpha. Problem will become very simple. Then you differentiate. Then where all dx1 by dt will become v1y. Hope everyone is able to understand this one. In the books, what happened? Directly they wrote some equations, very difficult. Nobody can understand, but there's a procedure here. Let's do one thing. Replace first xr is equal to in the old equation. So here, yeah, I'll bring this. XR, what I can write it as x and y by sine alpha whole square. Now we'll differentiate this. The overall energy has to remain constant. The overall energy has to remain constant. So differentiating this equation, can we replace better? I think we can go for V1x in terms of V2. Then again V1y in terms of V2. So I should, I'll primarily, I'll write equation 1. One, 2, 3. This is the 4. So what you should do now? substitute 1, 2, 3 in this and get everything in terms of E and so like a x1, y is there. So what is x1, y? Again, I have to show that negative displacement, what we have to bring? We have to bring x2, I think. Oh. Something went wrong here, no? I have to bring x2 into picture, not x1, y. Again, we have to take help of this. XR in terms of x1x. Again, we after differentiating x1x has to be replaced. So many calculations are there. Huh? Okay, I think now x1, y. I think this will be not advisable. Huh? Because again, we'll end up with this one only. This is not advisable. I will go for some other thing. This one will better replace XR in terms of this one, x1x minus x2 by cos alpha. Then because I had to bring v2 and x2 into the picture, then we'll get x1x. Again, we have to replace x1x, no? Then again, you have to bring the same equation. Then you have to replace x1x in terms of x2. I'll do one thing. I'll bring this later on. Let me write one more equation. Similarly, can we write even xr is equal to, problem will be solved here only, y2. Hope everyone is able to understand. I think this will be a very easy approach. Okay, this XR we got. Now we'll replace XR. Everything is available in terms of now V2 and X2. We can solve the problem very easily. First, you have to substitute 3 in 1. Then we'll get V1X in terms of V2. Substitute 3 in 2. Then you will get V1Y in terms of V2. Substitute 4. Then we'll go for all the substitution. Let me solve this now. So V1X, put 3 in 1.
M2 V2 by M1.
M2 V2 by this much. Alpha will be there, no? Okay. Only this one will come. Similarly, V1Y.
Sir, M2 V2 by M1.
V1Y will be VR sin alpha. So M1 plus. How much will get it?
M2 V2 by M1 only.
This
V1X, sir. V1X, M2 V2 by M1.
M2 V2 by M1.
Yes.
V1Y.
M1 plus M2 by M1. V2 tan.
M1 plus M2 by M1 tan alpha.
V2 tan.
V2 tan alpha. Yeah, put 3 in 1, put 3 in 2. Okay, now everything we have in terms of V2 and X2, there will go and substitute. Then the primary equation will write it some equation A or something. So these are the 5, 6, 4, 5, 6 in A.
Sir, I got time period expression, sir.
I'll write put 4, 5, 6 in A and differentiate. We are differentiate with respect to time. With dE by dt must be equal to 0. Equating this all solving, look at the equation. What is the equation you'll get?
Sir, time period equal 2 pi into under root k into m1 plus m2 by m1 m2 plus m1 square sin square alpha.
Okay, fine. I'll write the omega. I have answered. K by M1 M2 by M1 plus M2 cos
Plus
square
M1
alpha.
square.
Cos square alpha plus M1 sin square alpha. You should get this much only. Then only differentiating and equate to 0. So here, what is the other things like dv2 a2 is equal to dv2 by dt. And you have to show that acceleration a2 is negative proportional to negative of displacement minus x2. This will be your final equation.
Sir, or else we can write k into m1 plus m2 by m1 m2 plus m1 square sin square alpha.
Okay, further simplification. Yeah, it can be
Yes,
done.
sir.
Yeah, that'll be better. M1, M2. Okay, it can be further. Yeah. I don't have a place. I'll leave it here. This I'll send it to numerator. then M1, M2 I'll take common.
We'll get sin square alpha plus cos square equal to 1.
Go to 1. Again, one more sin square alpha will be left over.
Yes,
Okay, yeah.
sir.
Yeah, fine. Okay, correct. Okay, just I brought it so that so many other ideas are brought. A wedge constraint, the conversion of linear momentum,